Okay. Just now, what we've seen is we're only touching the moment. The second half, we'll look at what happened if we shift the force. Just now, we maintain the force setting, the force location, and then we see what is the reaction on project onto a certain member direction. Now, second half, we look at what happened if we shift this, for example, example 9, we shift this force to A. What happened? Okay, this session we look at moment of couple means if you move forces to something somewhere else, then it will happen lah. So the one that you see on here is a couple where if things that is balanced or not balanced, when you have a parallel force with the same magnitude but different direction and separate with a D, you will form a rotation. In this case, the diagram you see on the screen here, you're having a anti-clockwise direction motion. You have a two parallel force. For example, the steering on the car, you apply the same forces like this. So the steering will turn anti-clockwise. Okay. So the distance between the two forces is like the hand on the steering, the distance between your left hand and right hand. Okay. So the negative means the opposite direction of the another force. Okay, negative it means this one. Again, in your diagram, in your answer diagram, don't use negative value. Just show the direction. This is just to illustrate to you that we use negative to show that it's negative direction. Okay. So in this case, the resultant forces will be 0 because it's cancel each other. Right? So this direction cancel each other. Only the effect you'll see is rotation. If you have couple system, then you can cancel out the force and you're only seeing rotation. So if you like steering, so steering wheel, the one is go down, one is go up. So the two forces actually cancel each other. The force magnitude, the flux magnitude cancel each other. However, the result of these two will give you rotation. Okay. So there are two. The only effect is rotation, or if no movement possible. So if the thing cannot move, then there will a tendency. We use the word tendency, means it will try to rotate itself. You try to rotate. Tendency means there's a chances it will rotate. So this one is important in the screw design, especially in the aerospace. The thread of the way you unscrew and screw the thread is important because vibration is happening on the spacecraft, and it's not careful, then it will unscrew itself. The screw will unscrew, then it will loosen the thing. So in aerospace, usually we don't use the thread screw. We use the rivet just to fix it. Okay. So the result of these two parallel axes, parallel but different direction, will create couple moment. Okay. So, for example, any forces acting on a blue body, like you see here, and at the two location A and B, these two forces go parallel but different direction. It must be parallel. Parallel and different direction, it will create couple moment. So this one, if you see this diagram, it will have an F direction, F in B direction, negative F in A with the distance of R. And you observe from O, you have a R, O to B, O to A. So we label RB and RA. So as long as you see R and F, you create moment. So you have 2 moments here. So you have two moments, you sum them together lah. So how you write the sum of moment on this body? R cross F for the first one, and then R cross F for the second one. Then you combine the results lah. Okay, R cross B. So R cross B will create this direction by R cross B. So R cross B will another direction. Okay, it will look like this. And in early dot cross products principle, we can pull the factor out the RB, RB minus RA bracket cross F, because the magnitude force is same. Okay, or we just pull the negative to RA. So we are seeing the same force in the mathematic operation. Right. So see, this is the second equation for today. Couple moment. Couple, if you're seeing a couple, means two forces parallel. You use this equation, RB minus RA cross F. You calculate the vector between these two, then you put into the matrix here to calculate the moment. Means you change your Rxy into RB minus A in I, J, K direction. Okay. So you see there's a vector triangular here, RB is from O to B, RA is from O to A, and there's a R vector from A to B. It forms a triangular. So how you write the equation without looking at this one? You should be able to write, this is the final destination for all the vector. You should be able to see from O, this will be, B point is the final destination. O to B is a resultant. O to B is a resultant. So you should be able to write RB equal to RA plus R. You should be able to see. If you don't know how to see RB equal to RA plus R, go flip your vector chapter in mathematics. Okay. Or you rewrite the equation, you arrive at this one. Okay. So it is the same meaning. RB equal to RA plus R, or R equal to RB minus RA. You see this equation, you summarize with the R, you put R inside this equation. So you basically, you just take F multiplied by R, or cross product the perpendicular distance between the two forces. You still get moment in the couple setting. Okay. So it's also mean in couple equal to R cross F. Same, we're still applying M equal to R cross F. It's just that we're moving the force around. Okay. So this one, R cross F, you get a free vector, right? Free vector. So it can act at any point since M depends only upon the position of R, directed between the force. Okay. So this is the R between the forces, the two forces. So the moment will be at this plane. At this plane between the F and R. The moment will be happening here. So not, I just highlight, not using the position of RA and RB in your calculation when you have a couple moment, or you are changing one couple to another location. Okay. So this is the thing. So if you see couple moment like this, so it will rotate in clockwise direction, not clockwise, and anti-clockwise direction. So by still using the right-hand rules, right? Still using the right-hand rules. So scalar formula, to find the magnitude, we're still using F multiplied D. The distance is from perpendicular distance to the forces opposite. So you can take F minus F multiplied D, or you can F multiplied D, positive F multiplied D. You're still creating the same moment. Okay. Here again, we put, you see diagram negative means is opposite direction to the F. So when you do solution, you can remove the negative in the diagram by showing this kind of diagram. But means important is your arrow head where you point. Yeah, this is just to purposely show you that is opposite direction to the member another side. This is only for teaching purpose, for teaching purpose. But for your calculation in the real time or real in the work, don't use negative force. Don't write negative force like that. Just show the arrow if it's positive, if it's opposite direction. But in your calculation, yes, in your calculation, you use negative in your calculation. Okay. So direction of sense, this one is what you already learned. Right? This one, the blue color is on a piece of A4 paper. The back of your right hand is put on the paper. The thumb is showing the direction or sense of direction, sense of the moment. Okay. In vector form, you just put in IJK in your answer. Just now it's a scalar F multiply D. And if the question forces you to use vector analysis, you have to write IJK in your answer. If the question asks you to use vector analysis, and you won't score any marks because you don't understand the question. Okay. So don't come to me, hey, Dr. Ang, I'm get the correct answer. But again, the question asks you to use vector analysis. You have to show IJK in your answer. So you just pull out M equal to R cross F. In this case, R is the distance between the two couple force. So this is the one that I'm saying. So if you're like steering wheel or you're turning anything from between the two parallel force with the same magnitude, the keyword is same magnitude and parallel, parallel and opposite direction. It must be the same magnitude, means 30 Newton, 30 Newton, opposite direction, and the direction is parallel to each other. Then only can form couple. Okay. So you might ask, hey, Dr. Ang, what happens if I have different couple, a different moment? Let's say I have this 30 Newton here and this one 20 Newton, and it's parallel. It's parallel, but this side is 20 Newton. You need to see this diagram as couple of 20 Newton plus 10 Newton like this. This is couple plus another moment here. So this is the application. So again, just want to highlight what happened. You have a different value of force, but go parallel each other. You need to see as two system, couple system plus the normal moment that you learned previously. Okay. So this is just to illustrate to get the same moment or same turning motion, you can reduce the radius of your forces, but you need to turn harder at the shorter distance. Okay. So on the left, what is the moment created? What is the total moment created from this couple? Left hand side. F multiply D, scalar method. F multiply D, what you get? 12, what? Newton meter. What direction? and clockwise. Okay, but if you use right hand rules, it becomes negative value. Okay, so to get the equal moment, you need to when you reduce the distance between your two hands, you need to turn harder. The result is that you'll feel that you need to push harder, push or pull harder. Same magnitude, if you take 0.3 multiply 40, you still get 12 Newton meter. So this is the application of the second session. It will ask you when you transfer forces from 0.4 location to 0.3 location, because maybe you want to cancel out the force in the equation or in the diagram. You transfer the location of the force to a certain, then you need to change the force already, or you change the distance already. Now this is the application. Okay. 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 Same with steering wheels, but again, nowadays steering wheel is getting smaller and smaller because we have one devices called power steering. Okay. This one is another one. Just now is forces. Two forces, couple forces create one moment. And what happened? You have two moments. For example, resultant of couple moment means you have two moments. You want to join them together, right? So the couple moment, since two couple moment are free vector, this one means this is a result of couple forces from the earlier step. Then now you arrive at two resultant couple moment. They are called free vector. So resultant can be determined by moving them to a single point using vector addition. Okay, so how? You start with joining their tails at point O. Where's point O? Okay, point O. Okay, point O maybe here. Okay, so you extend the tail of the M2, extend the tail of M1, you join together. Okay, now the location of this moment doesn't care whether move up, move down is still turning anticlockwise. For example, you move M2, move up, it still rotate anticlockwise. You move down, doesn't care. So you can move the location of the moment. Same with M1. You move up, move down, also it rotate anticlockwise by pointing out from the paper, from the script. Okay, now is look at moment. So you can pull the two moments together and focus on one point, and you find the resultant of two forces. Similar approach to solving the vector diagram. Okay, moment, you will see moment ijk, you combine I together, combine jj together, combine kk together, you get resultant. Okay, the same lah. It's a vector addition mathematics like what you do for forces or other vector. It's the same. The concept is the same. Okay, so for couple moment, mr equal to m1 plus m2. If you have more than 3 or more than 2, then you just plus until you have all the moment together. Okay. If you have more than 2 moment, you still the same. Means you have two a moment m1 plus m2 plus m3. How to get m1? You still get r plus f plus. Okay, by using the same matrix, ijk, r second row, f the third row, same. Okay. So let's see example 10. This is 2D. So you can see you have more and more forces added to the diagram already. So yeah. Okay, so example 10 asks you to calculate the resultant couple moment of the three couples acting on the plane in the figure. Do you see three couple of forces? There are 6 forces there. but basically there are three couple, means two forces. F1 have two, F2 have two, F3 have two. So for example, F1 pointing down, F1 over here. So you have the first couple turning clockwise, F1. F2, this one and this one, this one turning anti-clockwise. The D is here to here. 3 is here. 3 is clockwise. So when you solve this kind of question, you need to decide what is the positive direction. Usually we just follow the right hand rules. If you look at your right hand, anti-clockwise is positive for all the moment. So if it's clockwise, then you put negative in your calculation. Okay, so you should able to see, right, the resultant of couple. You should able to, in your mind, you should able to do the calculation, right? The total resultant equal to M1 of F1 here. So you take what? 0.8, must same magnitude, must same magnitude, parallel, different direction of force. So 0.8 multiplied by 0.12, you get one set moment. This one anti-clockwise, this one clockwise negative, plus F2, 0.8 multiplied by 0.9. This one anti-clockwise positive. Second moment is positive. First moment is negative. Third one clockwise negative. So you take 1.2 multiplied by 1.5. You get negative value of moment. You add together. If add together get positive, means the resultant will be anti-clockwise. If you get negative value, means the resultant will be clockwise. But anyway, you just remain negative. If you get negative, don't go and overthink it, unless the question asks you to explain the direction of the resultant. Okay. So if you understand this one, we can go a bit fast. Right? You just substitute. The end answer for example 10 is negative 1.14 kilonewton. Remember to be careful on the kilo. Some question got kilo, some question don't have kilo. Some is meganewton, some is giganewton. Okay, so if you get negative, and earlier anti-clockwise is positive, so it also means that the resultant is clockwise. Okay. So this is the, if the question extend and asks you what is the resultant direction, your mention is anti-clockwise. You just write like this, right? Change the negative to behind, then show the direction. Okay, example 11. Determine the magnitude and direction of the couple moment acting on a gear. If you see any question with the force and angle, our recommendation always asks you to split the force in X and Y. Split them first by using sine rules and cos rules in trigonometry. This one got two forces. One is this direction, this direction. This one also same, split into go down and go to the left. So what is the, so when you split into X and Y, you will see two set couple. One is anti-clockwise direction. One is clockwise direction, also anti-clockwise. Yeah, this one when you split into two. Yeah, I believe you already know how to split already. If you're still weak in this one, please go and do homework. If you're weak, please go do homework. So I hope you can see that from the four forces, you can summarize into two couple forces or two couple moment, and both at a single point here. So basically, you can pull the red arrow to the point, here to here, here to here. Then this red arrow here, this arrow to here. Okay, let's say we focus on O. Moment, we need to tell where is the location of our focus. In this case, we focus on O, and anti-clockwise is positive. So the first set is, both set give you positive. No, one positive, one negative. Okay, let's say we put the x-axis couple. These two. These two will give you anti-clockwise direction. Then these two y-axis forces will give you clockwise direction. So your answer will get this one. Okay, the answer is positive. The answer is positive. It means it's anti-clockwise. Means what you put here is the same. You can do another one. If you don't want to put in O, another smart way is you cancel out all the force. If you move your finger, your focus of a moment to the point, the forces on the point will be disappeared. Means the moment at point A, the forces will disappear. The effect of these two forces will disappear, and you only considering the other forces acting on the diagram from A. If you calculate A, you have two moments. One is pointing up. You move this one to here. You're pointing up, so you will be 600 sine 30 multiplied by 0.2. This is a distance. F multiply D. This is the F. You extend your forces. And this is the perpendicular distance. So 600 sine 30, 0.2 meter. 0.2 meter. You get clockwise direction, negative. Then you pull this 600 cos 30 to here, to here. So 90-degree distance is here. So 0.6 cos 30, 0.2 will cause you anti-clockwise direction, which is positive. At the end, you still arrive at the same answer. There are two approaches. One, you focus on the point that given in a question. Sometimes if the question didn't mention anything, like this question, you can choose any point you want. You do the same for B also. For example, the B point here. Also same. Because moment only tell you rotation direction. It can move. Moment can move around on the plane. Only forces cannot. You move forces, it will create moment. But if once you find the moment already, you can place moment anywhere you want. Okay. Same. Same. This is another method lah. Okay. This is another method. Some people they think differently. I will suggest the first method in most of the case. If you want to do speed calculation, also can. By drawing two lines along the two parallel forces, and then find the distance between these two. But it will tell you need some trigonometry calculation if it's on the round body. So if you take forces 600 multiplied by the distance of this one, so there is a calculation for the trigonometry. You will arrive at the same answer. Okay, you go and find lah. Okay, so of course we don't like this method. Okay, this one is popular in the smart sensor. If you have computer to help you to calculate, then this one will be the fastest. Okay. Example 12 with the angle. Determine the couple moment act on a pipe segment AB directed 30-degree below XY plane. This one. AB go below, but there's a force here, force here. Couple moment acting on a pipe. So this one looks complex, but actually is quite simple. Right? What is the distance between the two couple? Huh? What is the distance between the two couple forces? If you use 0.15, it's wrong. The distance must be perpendicular to each other. It's this line. This is the distance between the two forces. So you have to put 1.15 multiplied by 13. Then you create a moment along what axis? X, Y, or Z. You pull out your right hand rule. So the moment is your finger. So if you put on X, then doesn't make sense. So you put on Y, you'll see it's along the Y axis. Okay. Yeah. So you have two vector analysis. You can use R m equal to 2 moment from O. If you want to pull from O this more lengthy way. If you look from O, R cross F, we have two set. R cross F, this one, remember, go down negative. Plus RB, go up positive. So RA is going 0.2, so 0.2J to Y direction. RB, you need to do calculation a little bit. RB is move in X and then move to Y. Your X is 0.5 cos 30, this direction. And then move to Y, 0.2 J, and then you move down. You move down 0.5 sine 30, which is here. Cross 100K. You arrive at the answer of this one. Okay. So you have I minus I cancel out. You get J negative. Okay. So another way is that you can use RB instead. RB in this moment of force at A is 0. Means you put your finger here. You don't need to look at 100 Newton anymore. You only look at the effect of this direction. Okay. So you calculate the RB, I and K. J is 0. Then you multiply IK, KK 0. You still get the same answer. Solution number 2, scalar method, F multiply D. You still get the same answer. FD. So yeah lah. So it depends. So if you look at A, you put your hand here. These forces gone. So you are looking at these forces is clockwise, but your finger tell you that anti-clockwise is positive. You're looking at this force, so this force is giving you clockwise direction. So it's a negative value. This is FD is only find the magnitude. You need to tell the direction. Okay, scalar method, FD is only get the magnitude, but you need to tell the direction, magnitude and direction. Direction is go inside the Y, minus J direction. Okay. Or you lazy to write this one, you go to your diagram and draw the direction of the forces, the moment. For in this case, you calculate this one, right? This one, moment of B, a moment of Y, you draw clockwise direction over here. If you're lazy to write this statement. Okay. Another example, 13. This one, this one will be very close to test 1 of final exam standard. You have a loss of dimension there. So replace the two couple acting on a pipe assembly by a resultant couple moment. So this is more on the design question. So let's say you already come up with a one prototype, and the customer say it's very troublesome. I need to put two staff to rotate the thing. Can I replace the whole system with only one switch? So you need to look at the system and use static chapter to replace the design. So here, how many force you have? You have 125 over here. Here also 125. So this one got one set of moment going anti-clockwise. This one also anti-clockwise. So you have two moments here, and you have three axes, x and y, x, y, z. So you have two methods also, vector analysis and scalar method. So I show you the vector. So you have two moments to solve. You should able to see you have two moments to solve. Two pair of couple. Okay. So one moment is like this. Moment two at here. Moment one at here. So when you solve this question, simplify your diagram. You draw the pipe, and then mark the point, and then you replace with this M1. You use the right hand rules, point the direction. So this is on the X direction. M1 anti-clockwise. M2 along this direction. M2 is anti-clockwise also. Remember to copy the slope of the member body. So this one give you 3, 4, 5. Remember to copy. This one also. So M1 you can calculate from the scalar method F multiply D, which is this one. M2, what's the magnitude of M2? 125 multiply. What's the moment created by this couple? F is what? 125. What is the D? This one. 0.3. You get this one. Okay, so if you use scalar, sorry, this is vector. Sorry, should be scalar. If you see FD, it should be scalar. The typo error over here is not vector. It's okay. So you use scalar to find the magnitude, and if the question asks you to put in vector form, then you just tell the direction. Use right hand rules. For M1, M1 is this direction towards X, so it's I. Bracket I. From FD, you find magnitude. Write the unit Newton meter. Okay. Then find the CD also same. CD, you can pick any point. You pick any point. Okay, M2, because it's slanted where the certain angle is not on the plane itself, so you need to move your forces in the vector form. So RCD is here. So we are looking at point D. So point D, you close D. 125 at D point gone. You only see 125 at C with the R distance like this. So D to C will be 0.3i because it's moving towards X direction. Cross FC, you need to split the forces. This one, forces, you need to write in FUC. Like that one I write on the whiteboard there. F equal to magnitude of force and the direction of forces. So forces magnitude will be 125, but it going direction. This one is X is 0, but it moved down and move to the right. So right, you don't have I, your Y is here to here. So here, to here in y direction is 4/5 j, right? Or you look at this triangular. This triangular, there's an angle here. You just put your angle here. So the y-axis is the base and the hypotenuse. Right, so that's why we use 4/5 for y-axis direction. This one is sine. So theta over here. So sine is 3/5. And it's go down. That's why negative. Go along y-axis is positive. Okay, so this is a cross products. Be careful on the cross products. Okay. Cross mean you use the circle diagram. I, J, K, anti-clockwise positive, clockwise negative. So I cross J, you get what? Positive K or negative K? Positive K. I cross K, you get negative J. Negative, negative, you get positive. Balance mistake usually here to here. Because you don't, if you don't understand this circle, you will make mistakes over here. Okay. Any question? Good. Everyone good? Can? All of you seems like this one too easy. Very boring. Okay. So another one is you replace. So you pull your moment and moment one, moment two to one of the point. You join the two end together. You put end together and you have a resultant. So you join this one and this one together. So basically, you just pull your I, pull your J, pull your K, add together. Okay, we have done with couple. We go simplify, simplified resultant. Okay, this one you read lah. This one you read. Mean we replace the force and couple moment with the equivalent system. If we see moment and forces, we can change the diagram into another form. So, for example, if you have a stick AB, but there's a force pulling at the end of the sticks, what do you feel at your hand? Is pulling out, right? I mean, if you stand at B, you're actually feeling the force at your hand. Okay, so you can replace the forces at the hand will be negative force and force. Basically, minus F at B. Minus F and F actually is cancel out the force. But you just mathematically, you add one pair of forces here. So that what is the result if you add this couple over here? What does it affect the whole system? It cancel out what? Do you see what happened to the F? This F, it can cancel out this force. It means you can shift your force from one end to another end as long as it's moving at the same axis. The force now is equivalent. So if you see a diagram, the forces at one end, you draw a line with your ruler. The force you can change the force location along the line. You can push along the force along the line from this diagram, the top to bottom. Okay. This is called principle of transmissibility. Means you can transfer the force from one location to another location with along the axis. So sometimes you see the question purposely mention this one, means you need to use this skill set in your solution. Principle of transmissibility. And they call this vector is sliding vector. For example, this force is called sliding vector. You can slide along the axis. It's called sliding vector. Okay. What happened now? Just now is go axis, right? Parallel to the axis. What happened if the force is perpendicular? What do you feel your hand? Your hand you will be rotating clockwise, right? So this is force above perpendicular. So if we want to cancel out the force, we just created something mathematically at your hand. Force and negative force actually doesn't exist, but you add in there just mathematically. So what happened to the force here? Okay. So you will feel something what? You will feel two action in your hand. You feel the stick will go down with the rotation at your hand here. So if you want to transfer perpendicular forces from one location to another location, remember the result will be moment and forces. You shift the forces perpendicular to the axis. You shift already with the distance. You transfer the force to one location plus the moment with the distance that you have moved. This one change to this diagram. Okay, make sense? And the direction of the moment must follow the forces. In this case, F point down, so you are feeling anti-clockwise direction. So the moment that you transfer also need to show clockwise direction. Don't go and change the direction. It's the reaction that you feel when you change the position of forces. So there are two diagrams, it's important. One is this diagram. If you change the location along the axis, it doesn't matter. You just pull the full magnitude forces along the axis and put any location you like. However, when you do modification on the perpendicular forces to the axis line, remember you are changing forces. Your result will get forces plus the moment at the other end of the point that you move. Okay. So the rest you read. Again, moment here is a free vector. It can act on any point of the sticks. Okay, so these are the conclusion between the two. Just be careful on the direction of the force that you look at. So if you have a couple system inside the system, you see moment, got force, got focus of R here. You can simplify to an equivalent single resultant force and resultant couple. Means if you look at the question in the test one or final exam, what you need to do, you summarize the force first. You get resultant of forces. Get the resultant of forces combined into moment. Then combine the moment together. Okay. Okay, the rest you read. Means these forces to the O will create one moment. This one will create one moment. Combine with this force, you get total resultant. Okay. Okay. Direction of M1, M2 will be like this. So it means force at O. So this one, F1, you see F1, F1 you shift again. This one, you shift your F to O already. It will generate force and moment. It will become F1 plus the moment. Okay, how to get this one? Because you shift F1 already. You shift F1 to here. F1 still there, but you shift perpendicular distance to the O. You shift down, you create one force here and another moment. What is the direction of moment? Use your right hand rules. So the direction of this one with the D here, F, D here, it will create anti-clockwise direction. Sorry, F, D, R cross F, R cross F. Yeah, so this one will create a clockwise direction because you're using R cross F. So you extend the F1 here, R cross to F, you'll get MO1 by calculation of R cross F. So you only look at F1. You are creating two effects. You shift F1 to this location, O location, you'll get F1 and M1. You do the same for F2. F2, F2 you can split into X direction, Y direction. So F1 you split into this direction and this direction. Right? So this direction, this direction. So your R will be this direction and that direction. So you have two moments, here and here. Then, and you know that M2. So sorry, this one you move your F2 to O location. You move F2 to here. You're creating F2 and MO2. And this one you don't need to generate anything. You just shift this M to the O. Yeah. So this means you are simplified the diagram when you solve. So when you solve a more complex system, what you do, you focus on the question. Let's say the question asks you to focus on O. So you move your forces to that location. You know that when you move, you're creating continue the forces plus the moment. If you shift perpendicular distance to the O, you are creating force and moment. Same with F2. You move F2 to O, you create forces F2 and the moment at O. Moment you continue to use lah. Okay. So here this diagram will give you M plus MO1 MO2. You can simplify into this diagram. Okay, maybe we'll stop here. We will continue this one on tomorrow. Okay, we'll continue this one tomorrow. We stop here.